All right, everybody, welcome to Math with Grace. Hello, for this video, we're going to be going through Pre-Algebra, book 809, lessons 11 through 15 on pages 43 through 66. We're going to start off here in lesson 11 with multiplying and dividing by negative numbers. Now, we solve inequalities the same way we solve regular equations, with one exception. When we divide or we multiply both sides of an inequality with a negative number, the direction of the inequality changes. So let me show you an example so we can see what that means, okay? If we have negative 2x plus 13 is less than 27, okay? To solve this problem, we do it just like we would solve any other equation. First, we're going to subtract 13 from both sides. We're left with negative 2x being less than 14, okay? Now, we're going to divide by this negative 2. When we divide by that negative 2, it changes our inequality, leaving us with x being greater than a negative 7, okay? When we multiply or divide by a negative number in an inequality, it switches around the inequality. And here's how I want you to think about it, or to look at it this way. If you're thinking to me, oh my gosh, why? That is so ridiculous. Look at it this way, okay? If I wanted to just change this x to make it positive, what would I do? Well, I would add a 2x to both sides, right? That's how we move the x to the other side, okay? So now we have 0 is less than 14 plus 2x, right? Well, now I would have to move my 14 to the other side so we could solve, okay, by subtracting a 14 from both sides. Now I have negative 14, okay, is less than 2x. Now we would just divide by our positive 2 like normal. And then we're left with x being greater than, right, negative 7, or negative 7 being less than x. These two things are the same, okay? But rather than move our x and move our constant around like that to change the sign for our x to be positive, we just need to make sure when we divide or multiply by a negative number that we just change our sign and rearrange it, okay? So looking at that, let's take a look at some of the problems. Problem 1a is negative 7x is less than 14, okay? We're going to solve this like we would solve an equation. We're going to divide by that negative 7. We want to get our x by itself, okay? Our negative 7's cancel, and now we have our x, but because we divided by a negative, we have to turn our sign around, okay? Now our x is greater than negative 2. Okay, remember when we divide a positive by a negative, the negative wins out, so our answer is going to have a negative. So x is greater than negative 2. Let's look at part B of this question. Y over 4, okay, minus 8 is greater than 12. All right, again, we're going to solve one step at a time. We need to get our y by itself. First, we're going to start by adding 8 to both sides. The opposite of what's being done, right? So they cancel out. So now we have y over 4 is greater than 20, right? Well, to get this y by itself, right now it's being divided by a 4. So we want to do the opposite. So we're going to multiply both sides by a 4, okay? That cancels our 4's here, and now we have y is greater than 80. Now in this problem, we did not have to multiply or divide by a negative number, so our inequality does not change, okay? It remains the same all the way through. It's only when we multiply or divide by a negative that we change the inequality. Let's look at part C. Part C is z over negative 6 plus 5 is greater than 3, okay? Again, we start out the normal way. We want to get rid of the constant on this side. We do the opposite. So it's being added, so we're going to subtract. They get canceled out. We are left with z over negative 6 is greater than, our sign hasn't changed yet, okay? Our symbol hasn't changed. What is positive 3 minus 5? Remember, if here's ground level, We're going up 3 pieces, right? But then we have to go down 5, okay? And that's going to be then what? We have a -2, all right? Now, z is being divided by a -6. How do we get rid of that? We do the opposite. So we're going to multiply both sides by a -6. What does that tell us about our inequality? Our inequality is going to change. We're we're multiplying by a negative number. Our inequality changes. Now we have a negative times a negative, so we know our answer is going to be positive. And so 2 6s is 12. So z is less than 12 is your answer for part C of number 1. Okay, let's take a look at problem number 2a. It starts out with x divided by -2 minus 9 is less than 0. So constant first, we want to do the opposite. So we're going to add 9 to both sides, okay? They cancel here. We're left with x divided by -2 is less than 9, okay? We're just moving a constant here. We don't need to change our inequality. But now we need x by itself. It's currently being divided by a -2. We want to do the opposite. And the opposite is to multiply by a -2, okay? That cancels our 2's here, but we need to remember we've got to change our inequality. So now x is greater than, okay? We have a positive number times a negative number, telling us our answer is going to be negative. 9 times 2, or 2 9s, is 18, okay? X is greater than -18. Let's take a look at part B. Part B is -2y plus 6 is less than 20, okay? Again, we want to move our constant first. It's being added here. We're going to do the opposite and subtract it from both sides. That leaves us with -2y being less than 14, okay? Now y is being multiplied by 2. We want to do the opposite, so we're going to divide it by a -2. Those cancel out. Our inequality changes. Our y is now greater than, okay? We have a positive number being divided by a negative number, so our answer will be negative. And 14 divided by 2 is 7. Our y is greater than -7. All right, let's take a look at part C. Last one for this section. We start out with 3z plus 5 is greater than -4. Okay? Okay, constant first. It's being added in our original equation, so we are going to subtract it from both sides. We are going to do the opposite. That leaves us with 3z being greater than, okay, -4. It's going down 4, right? And we are going to dig the hole even deeper by 5 more. How deep is our hole below ground? Here's our 0. We're going to -9, okay? So 3z is greater than -9. We are going to divide, because our z is being multiplied by 3, we're going to divide by 3. But it's a positive 3, so it does not affect our equality, okay? Our inequality, I'm sorry. So z is greater than, we have a negative number being divided by a positive number, so our answer will be negative. 9 divided into 3 groups, or divided by 3, is 3. So z is going to be greater than -3. So remember, as you're working through these, dividing by a negative, we switch our inequality, okay? Multiplying, where did one, right? Yeah, multiplying by a negative, we switch our inequality, okay? Keep an eye on what you're doing so you make sure if you need to change your inequality that you can do that properly. And that's multiplying and dividing with negative numbers in inequalities. All right, so lesson 12 involves using our sine, cosine, and tangent in application problems, okay? We're going to just look at, I'm going to actually put the book over here for this first example I want to go over rather than me trying to write it all out here. Let's just use what's in the book here. We're just going to go through this example just so you can see what that means. What does it mean to be in an application. It means we're applying it to something we could actually use in our real lives, right? Math in your real life. So here's how you would apply it. Okay, the sine, cosine, tangent. Here's your example. Bill wants to cut down this large pine tree behind the barn at his parents' farm. He needs to know the height of the tree in order to determine whether he can fell the tree without hitting the orchard fence 65 feet down the hill from the tree. Carrying an astrolabe. Here's what an astrolabe is here, okay? Probably maybe a word you've never heard of before. Perhaps it is, but that's what an astrolabe is. This part here is governed mostly by gravity, okay? And that's how you determine angles. It's a lot of times they use those on ships and things to help them find their place. But anyway, so carrying his astrolabe, because we've all got one just sitting around, Bill walks down the hill until his eyes are level with the base of a tree. So in all technicality here, and I'm terrible at drawing people, here's Bill, okay, and here's his astrolabe thing, all right? Here's his astrolabe. Here's Bill. His eyes, Bill's got long hair, okay? His eye, there he is. He can see the bottom of the tree, okay? So he walks down the hill until his eyes are level with the base of the tree. At this point, he knows he's 50 feet, or he can mark it and measure that he is 50 feet from the tree. Okay, he sights the angle with his astrolabe to the top of the tree. So he turns the astrolabe, however they work exactly. Probably should have drawn it up here more. Okay, so that it's lined up with the very tippity top of the tree, the very top that he can see, all right, from his position. And he sees on his astrolabe that that is a 55-degree angle from where he's standing, that he sees the bottom of the tree, to where he can see the top of the tree is a 55-degree angle. So how tall is the tree? Can he cut it down without breaking his fence? Well, here's the information that we know from this application, okay? The adjacent side, the side touching the angle that's not the hypotenuse here of our right angle, remember, this tree represents our right angle, okay? So the adjacent side, he knows, is 50 degrees. He is standing 50 feet. He is standing 50 feet away from his tree, right? And he knows that he has an angle of 55 degrees. That is the information he knows, all right? What information are we looking for? Well, we don't really care what the length of this hypotenuse is. That's not what we're interested in. We want to know, how tall is the tree? Well, we want to know what is the opposite side. What is the length of the opposite side of our angle? Our opposite side, okay? So our formula would be a tangent formula. We want to know the opposite side, and we have the information about the adjacent side. So we're going to use a tangent formula. Remember, tangent equals opposite over adjacent. This is the information that we can find. Looking on page 67 of your book, and I'll show you the chart when we start doing the work, but just flip to page 67 and there it is. We can look up a 55-degree angle has a tangent that equals 1.428, all right? Now we can put this information, substitute in what we know. We're going to substitute in. Well, we know that the tangent is 1.428. We don't know what the opposite side is, but we know that the adjacent side is 50 feet. We've substituted in everything we know. Now we have to solve for this opposite side like it was an x. We're trying to get it by itself. It's being divided by 50, so we're going to multiply. We're doing the opposite. We're going to multiply both sides by 50, okay? These 50s cancel out, and then we multiply 50 times 1.428, and we get that our opposite side, or the height of the tree, is 71 feet, 71.4 feet. Okay, but the fence is only 65 feet away, so it would not be a good idea for him to fell the tree in that direction because it will hit the fence. Okay, so this is an application problem. We have to figure out what we know and what we're trying to figure out, what we're trying to know, and then find the proper formula to solve for that information. All right, so if we look at problem number 1, we've got this drawing, and it's a little bit bigger in the book, but basic drawing, okay? Here's our angle, We have the opposite side we know is 18, and we have the adjacent side that we know is 20. And they want us to solve for this angle. Well, first of all, what do we know? Well, for part A, we know that we have the opposite and the adjacent side of this angle, or of this triangle, okay? We know what the opposite is, and we know what the adjacent is, okay? B, what is the desired information we're looking for? We're looking for the tangent of the marked angle, okay? Because that is the information we have. We don't have a hypotenuse. If you don't know the length of the hypotenuse, you cannot, unless you're solving for the length of the hypotenuse, you can't use any other information. We're looking for the tangent. We have enough information for the tangent. So part C is setting up the formula. Well, we know that tangent is equal to opposite over adjacent, okay? A tangent of an angle is equal to the opposite over adjacent. So for part D, they want us to substitute. Do we know what the tangent of the angle is? No, because we don't know what the measure of the angle is, right? That's what we're trying to solve for. But we know that the tangent of this angle is equal to 18, which is the opposite, over 20, which is our adjacent. Using your calculator, remember, we don't want to leave these as fractions. This is calculator usage time. They've got the little picture there on the book. Pull it out. Using your calculator, we divide 18 by 20, and we get that our tangent is equal to 0.9. Now, you know, on the chart, it goes quite a bit farther with the decimals, so I'm going to put in 0.900. Then, on page 67 of your book, you've got your chart, okay? We're going to look at the tangent side. This is the information that we have. We know the tangent is 0.900. Going down this tangent line, we're looking for 0.9. Okay, this whole first column goes from 0.0 to 0.577. Not what we need. Okay, we keep going down right here. 0.900. That is exactly the tangent that we have. Although remember, when we talked in class, sometimes you're going to have to estimate or round. It may not be exact, and you're going to have to figure out, should I go up one? Should I go down one? Just use your best judgment, okay? But here we have an exact tangent. So now we're going to move over and see what degree angle that is. That is a 42-degree angle. All right, so then for part, what am I at? E, what is the degree of the marked angle? It is 42 degrees, okay? So we're using our tangent chart for application problems, figuring things out. And that's how we work through it, okay? Let's take a look at problem 2. All right, for problem 2, I'm just going to go ahead and read what it states here. Bill wants to put up solar panels on the house roof for heating the water. Bill needs to know how many degrees are in the lower angles of the roof. Okay, this is the lower angle of the roof, in order to make his panel mounting brackets. If the roof rises 5 inches every time it goes horizontally 12 inches, what is the degree of the bottom of the roof? Okay, so known information. What do we know? Well, part A, we know the opposite and the adjacent, right? We know, here's the angle we're looking for. We know the opposite, it goes up 5 inches, and here's the adjacent for every 12 inches that it travels. So we know that our known information is the opposite and the adjacent. Okay, so what is the information we're looking for? Well, we're looking for the tangent of the marked angle, because we want to know what is the degree of this angle. The only way for us to find it with what's given us is by using the tangent. The tangent, okay, for part C, tangent of this angle is equal to the opposite over the adjacent, or 5 over 12. Okay, well, I'm in part D, sorry. Jumping ahead here. So our tangent is equal to 5 over 12. Opposite over adjacent. Again, calculator. Pull out our calculator, and we find out that the tangent is equal to 0.416666666. It goes on and on forever, amen. And then again, we turn back to page 67. I'm doing it sloppily. Sorry. Okay, we have our tangent. Just like before, we're starting in our tangent column. This time we're looking for 0.4166 or something close to it. We're going to come down. Okay, so here we have 0.04. Okay, or sorry, 0.404. And then it jumps to 0.424. Not exact, right? This is not an exact tangent of anything. So we have to make a good judgment. Would it be a better judgment to drop down to 0.404? Or is this our number closer to 0.424? If it were me, and it's my video, so it is me, I'm going to go with the 0.424. Okay, so now that that's what I've decided is closest, I'm going to come across and see what degree that is. Okay, and that tells me that this is a 23-degree angle. And when I say that, they use approximately. Okay, it's approximately 23 degrees because I did have to round, right? It wasn't an exact answer like problem 1. I had to round, so it's an approximate. It's basically 23 degrees. Okay, and that's fine. You choose your best. If you chose 22, I'm not going to mark it wrong because I know you at least were close enough and had the right answer. Okay, so let's take a look at number 3. All right, for number 3, it's set up a little bit differently. Okay. For number 3, and this is not a 0, that's just marking our opposite side, right? This side is opposite our marked angle. This side is adjacent because they're touching. And then we have our hypotenuse, which is always across from our right angle, okay? So in this problem, what is our known information? Well, we know the hypotenuse, right? We know the hypotenuse and the measure of the angle. That's what we have. We have the measure of the angle in degrees. We know that our angle is 48 degrees. It's been marked there for us. So for part B, it's asking what is our desired information? Well, in this case, in this question, our desired information is the adjacent side. That's where they've got their question mark. What is the adjacent side? So that's what we're looking for. So what is our formula this time? If we're looking for the adjacent side, we're looking for what? We have the hypotenuse and we're looking for the adjacent, so we're looking for the cosine this time. So we know that the cosine of any angle is what? Adjacent over hypotenuse. All right? Cosine is adjacent over hypotenuse. So now let's put in the information that we know. We have the cosine of 48 degrees, okay, is equal to the adjacent over hypotenuse, which is 20. Now this time, we have to look at our chart before we do our math because we need to know what is the cosine of 48 degrees. Otherwise, if we couldn't figure that out, then we would have 2 variables in this problem, and we can't solve for 2 variables at the same time, not with the information given us anyway. So we need to pull out our chart now, and we're looking for the cosine of 48 degrees. So now we go by the angle measurement, and we're going to move down until we find 48 degrees, okay? And then we're going to come over, make sure we're coming over to the cosine chart, or the cosine column, okay? And that tells us that the cosine of 48 degrees is 0.669. Okay, moving back to the problem, we can now say that 0.669 is equal to A over 20. Okay, now we're solving for A. We need to get A by itself. A is being divided by 20. So what do we do to get rid of that? We have to do the opposite. So we're going to multiply both sides by 20. Those cancel out, and we're left with A equal to 0.669 times 20 Pull out your calculators. Okay. And that tells you that A is 13.38. All right. So now we know that the length of A is 13.38. They want you to round to the nearest tenth. So we've got 13.4 equals A. We're rounding to the nearest tenth. We're using the 8 to round. Okay. So we are left with it being 13.4. Now, I don't know what these are inches or centimeters or feet or what, but if it's not labeled here, it doesn't need to be labeled in your answer. But that's how long this side is. Okay, we've just figured it out. So that's how we use our sine, cosine, and tangent in application problems. All right, for lesson 13, we're going to be looking at the volume of irregular shapes. Okay, so we've learned how to find the volumes of rectangles and triangular prisms and cylinders using the formula volume equals big B times H, right? We've also learned to find the volume of a pyramid or a cone using the volume equals 1/3 big B times H. And we've found the volume of a sphere because we know that the volume of a sphere equals 4/3 pi r cubed, right? But sometimes our shapes are not regular shapes. They're just not one thing. They're a bunch of shapes put together, but we still need to be able to find the volume of those. So let's take a look at a couple examples from the book and then we'll do the problem. Looking at the first example, we read that the grain bin has a total height of 12 feet. Okay, here's a grain bin from the top to the point. The cylinder part, which is this round cylinder part up here, is 5 feet. So it's 5 feet of the 12. So even if they just told us there, well, they do stop right there. So because we know that this is 5 feet of the 12, that tells us that this cone-shaped part is 7 feet tall, right? The radius of both the cone and the cylinder, so both this cylinder and this cone, is 3 feet. How many bushels will this grain bin hold? Well, our first thing we want to do is find the volume of the cone or the volume of the cylinder, but they're starting out with the volume of the cone. Okay, we just talked about how the volume of the cone is 1/3 big B times H. Remember, big B equals the area of the base. Okay, big B equals the area of the base. So to find the area of our base of our cone, this is a circular cone. It's the area of a circle. So it's 1/3. This is the formula for the area of a circle, pi r squared, times our height, right? So now they're substituting in all the information. 1/3 of 3.14, which is pi, times the radius squared, which is not radius times 2. It's the radius times itself. 2 radiuses, okay? Times the height, which we know as being 7 feet. Okay, pull out your calculator, multiply all this goodness, divide by 3, okay? Multiplying by 1/3 is the same as dividing by 3, and we get our answer that our volume equals 65.94 feet cubed. Remember, our volume is always going to be a unit of measure cubed, okay? Then next we find the volume of the cylinder. Again, volume of a cylinder equals big B times H. Big B equals the area of the base. This is the formula for the area of our base. The base is still a circle, okay? Pi r squared times our height. All right, so now we're going to substitute what we know. 3.14 gets substituted in for pi. Here is our radius squared, and 5 represents our height. Get out your calculator, boopity boop, multiply it all out. So we know that the volume of the cylinder portion is 141.3 feet cubed. Okay? Now, when they want the total volume, we just have to add them together. We're going to add the volume of the cone plus the volume of the cylinder to find out that the full volume of this shape is 207.24 feet cubed. Okay, now to find the number of bushels is just one extra step. If you look on your page 0, it should be there. If not, make note of it. That 1 cubic foot is equal to 0.8 bushels. So if we take our cubic feet, which we have 207.24 of them, and multiply them by 0.8, we would know that 165.729 bushels fit into here, or about 166 bushels will fit into this shape. Okay? We find the volume of this part. Then we found the volume of this part, and we added them together to get our full volume. Then we just had to take one extra step to find the bushels for this problem. I also want to look at example 2 today. It tells us that the vertical height of an attic, okay, is 6 feet. The ridge at the center of the attic is 18 feet, okay? What is the total volume of the attic in cubic feet? Now they've broken it down into 2 parts, pyramid and a triangular prism. What this looks like is if they cut this right here, this roof, and right here, okay, and then they took this piece and this piece and put them together, you would have a pyramid, okay? You would have a very low sloping pyramid, and this is a terrible drawing, but I think you get the idea. Okay, here's the center part where we put them together. Okay, that's how they're getting the pyramid. And then the center part is just this triangular prism. Okay, they've just taken these parts off and put them into one. Together, these 2 edges make a pyramid. Okay, so that being said, they're just finding the volume, or is this area? The volume of each section, okay? So the volume of a pyramid is 1/3 the big B times H, okay? So we've got 1/3. What is the area of this base? Well, it's a square. Its length and its width is all the same all around. Even though it's very bushed and flayed out, it is a square pyramid. So the volume or the area of a square is just the side squared, right? So we know that times the height, 1/3 times 34 times 34, that's side squared right here. They're 34 feet, okay? If we subtracted 18 from 52 and divided it in half, we would know that we would have 17 feet on each side, so it would make a perfect thing, right? So what we're left with then, multiplying it out, okay? Multiplying by 1/3 is the same as dividing by 3. So we take our number, divide it by 3, and we're left with 2,312 feet cubed, okay? Then for the triangular prism part, which is 18 feet, okay, and 6 feet tall at this point right here, right? The big B times the H. The base, okay, is this triangular side. And we find the area of a triangle is the base, 1/2 the base times the height. That's the area of a triangle, right? Our base is 34 feet, and our height is the 6 feet. So 1/2, 34 times 6, and then our height here is this 18 feet. So again, we punch the information into our calculator. Multiplying by 1/2 is the same as dividing by 2. So we divide our answer by 2 and we get 1,836 feet cubed. All right. Then to find the total volume, we add our 2 shapes together. We add our 2 parts together. 2,312 plus 1,836 equals 4,148 feet cubed. Our attic is 4,000 cubic feet, basically, okay? Each part separate, we find the answer for, then we add them together. Let's take a look at one of the homework problems. Okay, looking at number 1. Bill helped Gail's father calculate the volume of a second floor bedroom, okay? In preparation for installing a ventilation fan. The room is 14 feet long, with a cross section as illustrated. This is the cross section, just this flat piece right here, okay? They want us to find the area of some sections and then switch it over to volume. So what we're going to do for part A, okay, is find the area of the two trapezoids. Okay, remember, this is a trapezoid right here. This section and this section. They are equal trapezoids. Okay, they're exactly the same. See these little marks? See how this mark here has one dash and this has one dash? That means they are the same. So that's telling us that this 4 feet applies to this wall as well. They are equal. That's just so they don't have to write 4 feet over here and just be cluttered with numbers, right? So this one has 2 dash marks. So does this one have 2 dash marks. That means both of these lines are 7 feet. All right, they've only had to label one, but because they put the 2 dash marks, we know that that is 7 feet as well. Okay, so find the area of a 2 trapezoids, okay, which is just this section. Okay, what is the formula for an area of a trapezoid? Okay, the area of our trapezoid is equal to 1/2 times base 1 plus base 2 times your height. Now remember, these formulas are all on page 0. You should be using this page on your quizzes, on your tests. Okay, I'm not expecting you to memorize these formulas. I want you to be able to use these formulas, all right? So the area of our trapezoid is 1/2 times the base 1 plus base 2 times the height. Now remember, the bases are our parts that are parallel to each other. This side and this side are not parallel to each other. This side and this side are parallel to each other. That's what gives us our trapezoid. But how many trapezoids do we have? We have 2. So we're going to take this whole formula and multiply it by 2. So we've got 2 times 1/2 times, what is base 1? Let's call it 7. And base 2, 4. Okay? If 7 and 4 are our bases, what's our height? Our height is this down here, this 3 feet. All right? Now we've plugged everything in. We've substituted everything into our formula for part A. Before we start adding and multiplying here, we are going to reduce. 2 times 1/2 is just 1. So we can cancel those out. So we're left with our area being equal to 7 plus 4, which is 11, times 3. Our area is 33 feet squared. Remember, areas are always a unit squared. All right, let's take a look at B. Find the area of the rectangle. Okay, so this is the rectangle. This is what's left. Well, we know that the area of a rectangle is equal to the length times the width, right? So our area is equal to 7 times 6. Okay. Our area, 7 times 6, is 42. 42 feet squared. Together, these are both together are our big B. They are our big B. So, part C says, find the area of the base. Together, that's what these two things are. We've found the area of the base. We just had to find it in 2 different parts. So, the area of our base for part C is 33 plus 42, or 75 feet squared. All right? So, now we've got our big B. We need to now multiply it by our height, or the depth of this room. So if we take 75 times 14, all right, we will get the volume of our room. And 75 times 14, pull out your calculator. I have it written up underneath here, but tells us that our room is 1,050 feet cubed. We took a feet squared here, and this 14 was another foot. Together, they gave us a foot cubed. This whole space is 1,050 feet cubed. Let's take a look at problem number 2 on the next page. Okay. At an auction, Wilbur bought a fuel tank designed to fit under a toolbox of a pickup bed. Okay. Find the volume of the top tank. Okay, here's the thing. For this shape, we have to decide how we're dividing this. Okay, you can either draw your line straight down here and divide this into two rectangular tanks, or you can draw your line how I'm going to draw it and right here. Okay, now I've divided this tank into two rectangular shapes still. Okay, it's just how I chose to divide them. If you divide them up and down, your final answer will be the same, even though your answers in the middle won't quite match mine. Okay, but your final answer would be the same. So the first part, we're going right to the volume. Find the volume of the top tank. Well, the volume of a rectangle, remember, is length times width times height. So the volume of the top tank is going to be 6 times 10 times 48. Okay, if you get out your calculator, you'll calculate that the volume is equal to 2880. And remember, we're dealing with inches here. Inches cubed. Okay, that is the volume of this first top part of the tank. Okay, part B is, what is the volume of the bottom tank? It's the exact same formula. Okay, so here we're going to multiply. The volume is going to be equal to 22 times 4 inches times 48. Okay, 22 times 4 times 48. If you get out your calculator and calculate it, you will get 4224 inches cubed. All right. Part C says, what is the total volume? Okay, well, the total volume is 2880 plus 4224. Okay. Adding those together, we get a total volume of 7,104 inches cubed. All right. Then part D is, how many gallons will this tank hold? Well, now here's a formula we need to remember, right? 1 gallon is equal to 231 inches cubed. Okay, 1 gallon is equal to 231 inches cubed. So if we take our total cubic inches and divide it by 231, okay, that tells us that this tank can hold 30.75 gallons, right? Approximately. We're going to round, so it's approximately 31 gallons that this tank can hold. Okay? We took our two different parts. We found the volume of each part. Okay? We added that together to get our total volume. And then in this case, we had to take it one step further because they wanted to know how many gallons it would hold. So this tank would hold approximately 31 gallons. And this is how we find the volume of an irregular shape. We take the two parts, or maybe sometimes 3 or 4. We find the volume of each individual section and then add them together. The next section is section 14, lesson 14, and it's on percentiles. And I will not be teaching you about percentiles. Feel free to read it if you'd like, but there will be no quizzes or tests regarding percentiles, and therefore you do not need to do problems 1 through 4 in this lesson. And let's see here, nor do you need to do problems 23 or 24 for this lesson, but I am expecting you to do all of the problems in between there. Let's go and move on to lesson 15. All right, lesson 15 is all about combining square roots. What that means is that we can combine square roots the same way we combine all other variables, but we can only combine square roots that have the same number under the radical sign. They have to be like numbers, okay? Looking at that, we have, as an example, 2 times the square root of 3 plus the square root of 3, okay? These both have the same number under the radical sign, therefore they can be combined. And it's, in your book shows you this example, it's the same as adding 2 plus 1, right? Our coefficients, 2 plus our invisible 1, right? Times the square root of 3. Therefore, our answer is 3 times the square root of 3, all right? Looking at another example, What about 7 times the square root of 3 plus the square root of 5 minus 3 times the square root of 3? Okay. The only like numbers we have here are these two. Okay. So that leaves us with the square root of 5 plus 7 minus 3 times the square root of 3. Or the square root of 5 plus 4 times the square root of 3. Okay. This is what we end up with when we do this problem. All right. The square root of 5 doesn't change because it doesn't have any friends. Poor square root of 5. But we can add our 7. Well, we can take 7 minus 3, all right, and end up with 4 times the square root of 3. So let's take a look at some of our homework problems here. Number 1. Is this an A? Oh, it is an A. 1A. 4 times the square root of 7 minus 5 times the square root of 7. Okay. Well, I'm not going to write it like this every step. Please, if you need to, write it like this, if that helps you. But I'm going to look at it like this. What is 4 minus 5? Remember, if we start at 0 and we're going up 4, okay, and we come down 5, that leaves us where? At a negative 1 times the square root of 7. Okay. Part B for number 1. 2 times the square root of 3 plus 5 times the square root of 3 minus the square root of 3. Okay, these are all like numbers. They all go together. So our ending answer is going to better have a square root of 3 in it. All right. 2 plus 5 is 7. 7 minus 1, remember we've got an invisible 1 here. 7 minus 1 is 6. So our answer is 6 times the square root of 3. Part C. 3 times the square root of 2 plus 5 times the square root of 2. Again, our answer is going to have a square root of 2. 3 plus 5 is how much? 8. Our answer is 8 times the square root of 2. Problem number 2. A. Negative 5 times the square root of 8 plus 2 times the square root of 3 minus 4 times the square root of 8. All right. Well, we can reduce the square root of 8. That's not what we're talking about here today, but I want us to keep in mind that sometimes we can reduce these, right? But we're not doing that today. So our like numbers right now that we can combine are right here. Because 2 is all by itself, it's just going to remain the same, okay? And we know we're going to have a square root of 8, something. Well, what is negative 5 minus 4? So we're starting at negative 5, okay? And we're taking away 4 more spots. So where are we at here? We are at negative 9. So we have 2 times the square root of 3 minus 9 times the square root of 8. All right? B. 6 times the square root of 2 minus 4 times the square root of 3 plus 6 times the square root of 3. All right? We've got 2 like numbers that we can add or subtract, or we can put together. We can combine them. This is by itself. So we are left with 6 times the square root of 2. That's not going to change. And we know we're going to have a square root of 3 because it's in there. Negative 4 plus 6. Okay, if we're starting at negative 4, but now we're adding 6, okay, where does that get us? That gets us to a positive 2 times the square root of 3, right? 6 times the square root of 2 plus 2 times the square root of 3. Part C. 8 times the square root of 5 plus 2 times the square root of 5 minus the square root of 7. All right, these two are like numbers. They can be combined. We are going to have a negative square root of 7 left over. We are going to have some number with our square root of 5, okay? 8 plus 2 is 10, okay? Our answer is 10 times the square root of 5 minus the square root of 7. I want you guys to finish problem 3 on your own and whatever else needs to be done for this lesson. And then don't forget to do your unit test if you'd like extra credit for this book. and get me that when you're finished, and I will be emailing out your alternate tests to you shortly. Thank you so much, guys, and have a great week.